Okay, we're on problem number 92. I'm going to read it to you. I think it's written up, I'm going to say what I consider nicely. You make that decision yourself. It says a bottle of beer at room temperature, 75 degrees. All right, this is room temperature. The bottle of beer is at 75 degrees as well, by the way. It's placed into a refrigerator, and the refrigerator, I'm going to say, is another room. It's where you put this in, and the refrigerator is a stable temperature, and it's stable at 36 degrees. It works to maintain that temperature at 36 degrees. Provided it doesn't get overwhelmed, it's going to maintain a temperature at 36 degrees. You put an object in there, it's going to start to cool. And what they say is after 40 minutes, the beer cooled to 60 degrees Fahrenheit. They go on to say use Newton's law of cooling. Let me review that with you. That's a differential equation, and that differential equation is the change in temperature of the object with respect to time is equal to some constant times the temperature of that object minus the stable room temperature, all right? So then the question comes is, do I know these things over here? Well, I know the stable room temperature, but I don't know the K, all right? So what do? I write down what I do know. So I write down dt, that's a change in temperature at the time, is equal to K, no idea. T stands for the temperature of the beer in the refrigerator at time T. What's minus 36 represent? The stable temperature of the refrigerator, all right? Now, by the way, what I got to do now is separate the variable. Let me do that for you. So it would be dt 1 over t minus 36 equals k dt. What do? Integrate both sides. Relatively simple to do, by the way. You get the natural log, uppercase T, that's the temperature of the beer bottle in the refrigerator at time T, is equal to K T plus some constant of integration. Whether I put it on the left or right doesn't much matter. Now you notice I put the parentheses on the T minus 36, and the reason for that is it's the temperature of the beer, it's going to certainly go towards 36, it's cooling down. But what I'm going to say is never going to be negative, right? And certainly over time it does cool, but we're looking at, on some time interval where it starts at 0, it goes off to, infinity, let's say. So I'm going to say that's a differential equation, and I want to show you where that's written. It's written over here. I just solved the differential equation. I still don't know K, and I don't know T. So what do? I go back to the conditions that they've given me. Let me start to erase now. And they gave me some conditions. They gave me actually 2 of them. And what did they tell me? They told me that at T, the temperature of the beer bottle at 0 was room temperature, and that means it's 75 degrees, all right? Let me not put the degree symbol over there. It should say 75. So I write it down. Now what am I doing? I'm taking this. I'm going to write that down now. So I know that T is 75 when the little t, that's the time by the way, is 0. So I write it down. What do you get? Natural log. And the t is, let's see, 75 minus 36. And that equals k times 0 plus c. Well, I think I know what c is now, because k times 0 just disappears. The k disappears. I get c equals the natural log of 39. Okay, I got C. All right. Now, I'm going to get my eraser out again. I'm going to start to erase this business over here. I'm done with that. And I'm going to write the other condition down. And someone says, what's the other condition? Well, let's write it down. The other condition was the temperature the beer was, it's in the refrigerator now for 40 minutes. It dropped to 60 degrees, by the way. So what does it mean? It means the big T is 60 when the little t is 40. Well, let's go for that now. What do I get? I get the natural log, and the t now is 60. Again, we're still using this over here. So it's going to be 60 minus 36 equals k. I don't know what k is. I do know that t now is 40, though. And then what do I get? I get plus c, And I know C, it's over here, C is the natural log of 39. I think I can figure out K now. There's only one unknown. What do you get? The natural log. 60 minus 36 is 24. I'm going to subtract the natural log of 39 from both sides. And I'm going to divide through by 40. And that gives me K. I'm going to simplify a little bit. I'm going to say 1/40th. I'm using the rules of logs. That's 24 over 39. And I think I can do that now. So I'm going to write the K down. And it's going to be 1/40th. No, I'm not going to use a calculator. And what do you get over there? Well, 24 divided by 39, both of those numbers are divisible by 3. You would get 8/13. All right? Let me get my eraser out. And I'm pretty satisfied that these things are working out, at least doable for me. Like I know what K is, I know what C is. All right, I know those two things, and that's how I'm going to write them down that way. Now, then what do? You're going to, oh, by the way, I want to point out these things are written down for you. For example, this here is written here, and the K is written over here. All right? The next time I write it down. And write what down? I'm going to write the differential equation down now. What's that going to be? Not the solution to the differential equation, I'm sorry. So I'm going to write natural log. And then I'm going to put, T. That's the temperature of the beer at time T, by the way. Minus 36 is equal to K. K is 1/40th. And that's going to be natural log of 8/13. T plus natural log of 39. All right? So they got a question. And their question is, what is the temperature of the beer at 80 minutes? Well, let's go back over that to make sure you understand that. So 40 minutes in, it's 60 degrees. They want to know another 40 minutes in. That's going to be 80 degrees. So they want to know what T is at 80. What the temperature is at 80. I don't know. I just plug it in. Now, suppose, what are you plugging in? Well, I'm plugging in this thing over here, which is T. T is 80. But I don't know the T at 80. I just plug it in. Let's write that down for you. So you can get natural log, I don't know the T, minus 36 is equal to, and let's write this down. So the T is 80. So what are you going to get? You can get 2. By the way, I'm plugging it in here. I get 2 because, 80 divided by 40 is 2. The natural log of 8/13. I'm not minus, but plus the natural log of 39. Boy, there's a lot of logs there, aren't there? Let's write this down. The natural log of T minus 36 equals the natural log. I'm going to take the 2 up, and that's going to be 8 squared over 13 squared. I'm sorry, plus. I keep saying that. Plus the natural log of 39. Okay, let's keep going. The natural log of T minus 36 is equal to, well, I think I can do that. And what do you get there? You get the natural log of 39 times 8 squared over 13 squared. Let's keep moving. T minus 36 now. Again, the log of T minus 36, log is the same thing. It's 39 times 8 squared over 13 squared. T, and this is T at 80 now, is the same thing as 36 plus 39 times 8 squared over 13 squared. All right? So T at 80 is going to be 36 plus, I'm going to say, I don't mind using calculator, but I want to write down, it's really not bad to write it down. And the reason for that is, 13 goes into 39 3 times. So you get 3 times 8 squared is 64. And I get 13 in the bottom. All right? Now granted, I'm going to call it quits there and take the calculator out now because I don't really feel like dividing by 13. Although it's doable. It is doable. And if you do that on a calculator, you're going to get approximately 50 point. I'm going to look. I'm looking at the what I got over here. I did this using Sage, by the way. 50 point some odd degrees, by the way. So about 50.77 degrees. All right. So again, after 80 minutes, the beer is cooled down to 50.77 degrees. Thank you.